Okay, so if this is like, if it is not clear, maybe you will get some interruptions due to rain, but in case, don't worry, I'll give you the required recording, so don't worry about that. So anyway, so let me proceed from the place that we have stopped last day. Actually, we were discussing about the paper, and there are a few things to discuss today. Last day we discussed about our term test paper, and we were discussing about number systems, and today we have to discuss few about the logic gates. So those who missed the lesson, the number systems and logic gate, I'll revise that quickly, right? I'll revise that quickly. So is it not clear? So can't you hear clearly? Okay, let me change the question, change the connection a little. Let's try. I'm going to change the connection. Okay. Timasha, Vanshika, is my voice not clear?
Clear.
Clear, no? So I think then I think the problem with your side, right? Sandesh. So please check your side also. So others are telling that it's okay. Maybe little drop in your side, right? Okay. Right. Let's go to the discussion. And last day we were discussing about the non-only implementation, sorry, no-only implementation. That is about your paper. So the question number is question number 10, I guess. Yes, it is question number 10. So I asked non-only implementation or no-only implementation, and I have given the explanation last day. So why we need universal gates? Why we need universal gates? Universal gate means universal gate එකක් කියන්නේ පුතේ යම් කිසි අපිට අනික් gates ගොඩක් තියෙනවානේ. Logic gates ගොඩක් තියෙනවා. අපි දන්න basic gate තුන තමයි AND gate, OR gate, NOT gate. Those are the three gates that we know. එතකොට ඊට අමතරව අපි තව දෙකක් ඉගෙන ගන්නවා O level ICT වල NAND gate සහ NOR gate. හරි. ඉතින් ඔය gate එක තමයි අපි ඉගෙන ගන්න. Universal කියලා කියන්නේ මේ තනි gate එක පාවිච්චි කරලා you can use this single gate and create all other gates. මේ තනි gate එක පාවිච්චි කරලා අනිත් සියලුම gate හදන්න පුළුවන් නම් අපි කියන universal කියලා. එතකොට දැන් ගිය සතියේ අපි කිව්වේ no gate එක universal පාවිච්චි කරන්න පුළුවන් not gate එක හදාගන්න. ඒ කොහොමද? no gate එකේ අග්‍ර දෙක input දෙක. If you merge, if you solve two inputs, the output will be not. Because you see, if inputs are A and A, that will be taken and O. After that, it will be inverted with this part. So ultimately, you will get input 0, you will get output 1. Input 1, you will get output 0. So that is our expectation. ඒකනේ අපි බලාපොරොත්තු වෙන්නේ. අපිට ඕනුනේ බිඳුවක් දුන්නම එකක් හැදෙන්න, එකක් දුන්නම බිඳුව හැදෙන්න. ඉතින් මේ අග්‍ර දෙක සම්බන්ධ කරාම after combining these two, we can do this. Similar to this, if you use NAND gate, you can create. Okay, let's see. We have our virtual testing environment. අපිට තියෙනවා virtual testing environment එකක්. මගෙත් එක්කම ඔයාලටත් මේක ඇත්තද කියලා බලන්න පුළුවන්. Right, okay. So let's move to that virtual testing environment quickly, right? That is logic.ly/demo. හරි මේකට යන්නකො ඔයාලත්. You can also go this. You don't need the samples. හරි මේකට යන්න. මේකට ගිහිල්ලා අපි බලමු whether it's giving the same. You can test. Yes, I'm discussing the part of paper. But again, I'm revising the things that we learn. Not just the paper, right? Not just the paper. I'm discussing the related theory also. Hari, then Q&A, දැන් අපි ගමු NAND gate එකක්. Here I have NAND gate. Here I have NOR gate. Right, here I have NOT gate. So you know the behavior of NOT gate. It has only one input. And if you test the output using a bulb, so you know the behavior. When it is 0, when the switch is off, that means when it is 0, it will output 1. But when it is 1, it will output 0. That is the behavior. 0 nan 1, 1 nan 0. Ekani not la heti. Eka thama not gate ege behavior. 0 dunnot 1, 1 dunnot 0. Hari, ඉතින් ඒ වගේම බලමු දැන් මේකම හදා ගන්න පුළුවන්ද කියලා අනිත් එකනොත්. So what I'm going to do is I'm going to combine both. දෙකම මම combine කරනවා. එක අග්‍රයකට combine කරනවා. සම්බන්ධ කරලා ඊට පස්සේ අපි දැන් bulb එකක් දාලා බලමු. Okay, දැන් ඔන්න 0 දුන්නා. 0 දුන්නම 1. 1 දුන්නම 0. 0 දුන්නම 1. 0 dunnam, when you give 0, it's output 1. But when you give 1, it will output 0. When you give 1, it will output 0. Right? Now, agree with my statement? Do you agree with my statement now? මෙතුල් ගේ තියෙන ප්‍රශ්නයක් තියෙනවා. මෙතුල් ඔයා audio join it audio කරලා නැහැ. කොහොම join වුණොත් පුතේ වාට ඇහෙන්නේ නැහැ. කොහොමද මේ පණිවිඩයට දෙන්නේ? මෙතුල් join with audio. Otherwise, you will not hear. Not here, sorry, HEAR. Easy, fix the issue. It seems no. So please tell him, somebody please send a message to him. Just need to join with audio, otherwise he will not hear. Right? He will not hear the lesson. Okay, then. Okay, if you want, I can just display in the screen. Okay, don't know whether he corrected that, but this is for him, right? Okay, right, then let's go back. Let's do the same with this. Merge in both. And now you can see when it is 1, it's 0, but when it is 0, it's 1. But 0 වුණාම 3ම 1, 1 වුණාම 3ම 0. ඒ කියන්නේ not එක අපිට හදා ගන්න පුළුවන් NAND එකෙනුයි no එකෙනුයි දෙකෙන්ම හදා ගන්න පුළුවන්. right? NAND එකෙනුයි not එකෙනුයි දෙකෙන්ම හදා ගන්න. ඊළඟට අපි බලමු O එක හදා ගන්න පුළුවන්ද? O එකත් මේ වගේ තමයි. O එක ගත්තම O එකේ හැසිරීම ඔයගොල්ලෝ දන්නවා. What is the logic of O gate? What is the logic of O gate? Yes, can anyone tell? Akash, what is the logic of O gate? Yes, your microphone is not clear, right? Okay, Vanshika, Deomi, logic of O gate. If both are 0, if all inputs are 0, it will output 0. That is the logic. If all are 0, if all inputs 0, this will output 0. That is the logic. Right, okay. Somebody has sent in the chat. Right, you are always telling the other side, right? I don't know. So don't tell that. So it's okay to tell that side, but the easiest way to remember, right? What happened? So if there are 3 inputs, what happened 4 inputs? The easiest way to remember, If all are 0, it's 0. Because no need to remember other three status. Tama status තුනක් තියෙනවා. ඒ status තුන තමයි 1 0 වෙද්දි මොකද වෙන්නේ? 0 1 වෙද්දි මොකද වෙන්නේ? 1 1 වෙද්දි මොකද වෙන්නේ? No need to remember that tree. Because 1 1 is also 1. 0 1 is also 1. 1 0 is also 1. But 0 0 is 0. Remember the special case. 0 0 is 0. Then other cases all 1. 0 0 is 0. If all inputs are 0, it's 0. Other cases, it's 1. Right? This is the truth table. If you draw a truth table for this, you can see. So a special case is this. If both are false, false, or both are 0, 0. That is the special case. Okay, let's go to the next one. Now, can we create this OR gate using these gates? So that is my problem. So yes, you can create. So in universal gates, it is possible to create OR gate using the other gates. Here, see this. So OR gate I'm going to create that OR gate using NOR gate. If I have NOR gate, right, I need to behave similar to OR gate. Then what I'm going to do, I'm using another NOR gate and merging these edges. Now giving the same inputs and see. Let's give the same inputs and see the behavior. Also giving a bulb to see. Now see, you can see this. If both are 0, it's 0. This one is also, both are 0, it's 0. But if it is 1, you can see it's 1. 0, 0. If this is 1, again this is 1. If there is 0, 0. Both are 1, this is 1. This is also if both are 1. So what we have done, we have added the NOT gate that we just created. This NOT gate we placed here. Then NOR gate is converted back to the OR gate. That is possible. NOR gate can be converted back to the OR gate. Similar to that, using NAND gate also you can do the same. Here I have NAND gate. Here I have another NAND gate. So I'm getting another NAND gate. Altogether 3 NAND gates. Just connecting this. And to the switch, I'm connecting both edges. To these switches, also I'm connecting both edges. So now I'm going to connect the bulb. Both are 1. This is 1. Still 1. This one is 1. Still 1. And this one is 1. Still 1. Both are 1. Still 1. But both are 0. If both are 0, this is 0. Both are 0. This is 0. Both are 0. This is. So you can create OR gate even using NAND gates. So that's why it's called universal. NOT gate can be created using NOR gate. So let's do it in a better alignment. I'm going to keep this here, NOT, and the bulb here. So you have created the same using this bulb and this NOT gate, and you have created the same using this bulb and this NAND gate, NOR gate. So all three are equal. Here also all three are equal. So similar to that, I can create soft status. Similar to that, I can create AND gate. So here's the normal AND gate. So what is the logic of AND gate? So I need your answers, quick answer. So who's the one? Who's going to give the answer first? How this answer then? AND gate logic. What is that?
If all inputs are 1, 1.
Yeah, if all inputs are 1, it's 1. Otherwise, it's 0. If all are 1, it's 1. Otherwise, එකක් හරි බිඳුව නම් බිඳුව. දෙකම බිඳුව නම් කොහොමද බිඳුව? දෙකම එක නම් විතරයි. If both are 1 only, it's 1. Okay, now I'm going to use NAND gate and simulate this. Here I'm combining A and B and another NAND gate, combining both to this edge. and connecting the bulb. Sorry, both are 1. This is 1. Similar to that, using NOR gates also, I can do this. Using NOR gates also, I can do this. I'm using NOR gates. So here's my NOR gate. Just connecting to this one and this one. This NOR gate, I'm connecting. Oh no, this is OR gate. This is NOR gate. Connecting to this one to create an OR gate. And another OR gate, NOR gate, to connect this one. And you can see the final output is when you combine this. If both are 0, 0, if both are 1, you can see it's 1. Right. That means using NAND gate and NOR gate, you can create any other gate. You can create OR gate, you can create NAND gate, and AND gate, and you can create NOT gate. All 3 gates can be created using NAND and NOR gates. So that is there in your book. So when you go to the page number here in the Sinhala book, it's page number 131. So let's say whether, I don't know whether it's the same page in the English book. So let's go to the English book. This is grade 10 English book. And let's go to the page number 131. 131. Just that. Still 45, 57, 81, and 108. Okay, this is the page, and it's 124, the page number 124. You can see these no only gates and NAND only gates. So why these ICs are having, why these integrated circuits are having no only NAND only? Because you can utilize and create any type of gate. So that was discussed previous day. Okay, you can take a screenshot of this. Take a photo of this, screenshot of this quickly. Take a screenshot of this. Try to do the same in the simulation. So I have sent the link, logic.ly/demo. I have sent the link, logic.ly/demo. Try to do and understand by yourself, right? Try to convert the circuits and try to understand by yourself. So I'm going to the examination paper back, and so please add this part to your note. Any other logic gate, please write down. Any other logic gate can be created by using NOR and NAND gates. NOR and NAND gates. Therefore, these two are called universal gates. Therefore, these two are called universal gates. And kindly draw the IC. So this is example IC with universal gates. So this is NOR only. So this is in page number 124, but better you write down and show this. Quickly write down. Right, let's go to the next question. So it's asking technology used in the third generation. Easy question. So it is IC, integrated circuits. First generation vacuum tube, second generation transistor, third generation IC, fourth generation large scale integration and very large scale integration, or we call microprocessors. That is fourth generation. Fifth generation, artificial intelligence and ultra large scale integration. That is generation 5. Okay, so add the binary number, this to the octal number and hexadecimal number. So you are given 3 type of numbers. The first number is base 2 number. Okay, how you add? What is the easiest method to do this? So if you are given a binary number and you are given a octal number and you are given hexadecimal number. So what is easiest method of doing that? And asking the answer in hexa. So this is octal. They are saying this is octal and this is hexa. And this is binary. And finally, final answer is asking in hexa. So what is the easiest way? Yes? What is the easiest way? 3 numbers are there.
All the numbers into binary.
Yes, convert all the numbers into binary, then add the binary number and then give the answer. That is the easiest way. Right? Convert all to binary. And how do you convert to binary? So you should know how to convert binary to octal. So that we have already given. Right? But if you cannot, so if you are like, so if you have not come that day, so what you can do is you can write down. So I'm giving you the chance to write down this, right? So you should know how to convert binary to octal. There are 2 methods. 2 methods. Number 1, method 1 is, so you can convert by considering the positional values, right? I'll explain, right? I'll explain how to add binaries, all this, and I'll explain, right? First of all, you should know how to convert. Right. So the first method is consider the positional values weight, basically we call weighted values, and multiply by digit and sum them. And take the sum. So by doing that, you can convert that to decimal. After converting decimal, so what you can do that, after getting the decimal, divide by 8 and convert to octal. So that is how you convert binary to octal. So please write down. I have shown the steps, right? So here the binary number, example, let's say example, binary number 100101 is given. You have to take the positional value. This positional value is 2 to the power 0. දෙකේ බිඳුවෙනි බලය තමයි මෙතන ස්ථානීයකය. එතකොට මෙතන දෙවෙනි එකේ ස්ථානීයගේ positional value එක 2 to the power 1. දෙකේ එක්වෙනි බලය. එහෙම නැත්නම් දෙකේ කොටවල්. මෙතන ස්ථානීයගේ 2 to the power 2. දෙකේ දෙවෙනි බලය එසේ නැත්නම් අපිට කියන්න පුළුවන් 4 කොටවල්. දෙගුණ වෙනවා මේ. 1 1 දෙගුණේ 2 2 දෙගුණේ 4 4 දෙගුණේ 8 8 දෙගුණේ 16 16 දෙගුණේ 32. So ඔයගොල්ලන්ට හම්බ වෙන්නේ කොහොමද? RAM එහෙම හම්බ වෙන්නේ තේමනේ 1GB RAM 2GB RAM 4GB 8GB 16GB memory card හම්බ වෙන්නේ කොහොමද? 1GB 2GB 4 8 16 32 right. එතකොට ඕනම දැන් කම්පියුටර් එකේ ගොඩක් devices වල measure කරන්නේ මේ binary system එකට. එහෙනම් තමයි හැම වෙලෙම double වෙන්නේ. දැන් mobile phone වලත් එහෙමයි. ඒවට තියෙනවා නම් 8 megapixel camera ඊළඟට එන එක 16 megapixel වෙනවා. ගොඩක් වෙලාවට binary countable value එකක්. නැත්නම් 8GB RAM එකක් තියෙනවා නම් ඊළඟට එන එක 16GB. So that's the nature. Right, okay. So quickly write that this is the first method. Take the positional value. Positional value එක එකේ ගොඩවල් එකක් තියෙනවා. Positional value එක 4 4 ගොඩවලුත් එකක් තියෙනවා. positional value 32, 32. 32 ඒවත් එකක් තියෙනවා. 32 into 1 plus 4 into 1 plus 1 into, because these are 0. 16s you have 0. 8s you have 0. 2s you have 0. 1 from 32, 1 from 4, 1 from 1, altogether value is 37. And then this is method number 1. Then what you have to do? 37 divided by 8. 37 වලට 8 ඒවා 4යි. 8 වරක් 4 32යි. ඉතිරි 5. So the number is 48 in octal. So this is the first method of converting. Just write down this quickly. Okay, so the second method. First method is this. First method is you convert binary to decimal and then decimal to octal. ඒතර වැඩ දෙකක් තියෙනවා. හැබැයි එහෙම කරන්න පුළුවන්. කවන්නේ. ටිකක් වැඩ වැඩි. හැබැයි ඊට වැඩි ලේසි if you refer to this table. Just refer to this table. දැන් මේකේ තියෙන pre-computed value. කලින් ගණන් කරලා නම් හදපු values ටික. ඒක ලේසිත් අනිත් එක බලන්න. 0 1 0 1 0 1 0 1 pattern එකක් නෙන්නේ 0 1 0 1 0 1 see. Then 0 0 1 1 0 0 1. 4 zeros 4 ones. It's a pattern. Where pattern එක බලාගෙන, so what you can do, method number 2. Method 2, write 3 by 3. 3 from left. Start from the left side and write 3 by 3. So this is the number. මේ number එක තියෙන්නේ. ඔව් වමෙන් පටන් ගත්තා. මේ 3 වමෙන් 3ක් ගත්තා. Next 3. 3 ගත්තා. 3 by 3. 3 by 3 ගත්තම මේ 3ෙන් කියන්නේ මොකද්ද? 101. 101 කියන්නේ මේ 101 කියන්නේ 5. 100 කියන්නේ 4. එතන 45. This is easy. එතන binary to octal කරන්න මෙහෙමයි. ඕගොල්ලන්ට අහන්නේ paper එක අහන්නේ මේ paper එකේ අහන්නේ essay එකේ නම් you have to write the long method, right? If it is in essay paper asking with the steps, go for the standard long method. But if it is MCQ, go for the short method. Right? Short method is easy. You can just look at the table and write the values. That is the short method. So please write the method 2 also. Method 2 එක clear කරගන්න. You will be disconnected now because of this Zoom 40-minute time limit. Please rejoin to the same link, right? A link එකටම join. So please write the second method also.